NASA's Lucy asteroid probe is set to begin its 12-year space odyssey next month. An artist's conceptual drawing released June 13, 2002 depicts a Jupiter-mass planet orbiting the star 55 Cancri, about 45 light-years from Earth. A possible moon around the planet is shown because such moons are thought to be common around this type of planet, but no moon has been detected. NASA's next mission will involve a 12-year journey of the spacecraft that goes by the name Lucy. The endeavor of the United States Space Agency seeks to learn more about what lies beyond the outer solar system. NASA Lucy spacecraft launch. As per WFTV, both NASA and the United Launch Alliance, or the ULA, confirmed that the launch of the Lucy spacecraft from Space Coast in Florida is all systems go. NASA is partnering with ULA to send Lucy to space atop its Atlas V401 rocket. To be more precise, the launch of NASA's Lucy was scheduled on Saturday, October 16th at exactly 5:34 a.m., but that is if the good weather persists and the launch goes smoothly. The liftoff will kick off a landmark mission that will see Lucy get up close and personal with 8 different space rocks over the next dozen years. Lucy principal investigator Hal Levison of the Southwest Research Institute, SWRI, in Boulder, Colorado, said during a news conference on September 28th that they were visiting more asteroids than any other spacecraft in history. Lucy will take the distance crown from NASA's Juno probe, which had been orbiting Jupiter since July 2016. Nevertheless, the Lucy spacecraft will still undergo another launch readiness review on October 13th before its scheduled blast-off. Last Friday morning, or on October 8th, NASA officials concluded its second-to-the-last flight readiness review with no unprecedented issues. It is worth noting that this Lucy spacecraft is expected to break 2 notable milestones. One is to be the first space vehicle to specifically visit Jupiter's asteroids. On top of that, the mission is also slated to be the first to go to the outer solar system and make a flyby on Earth. Lucy's main science targets are Trojan asteroids, space rocks that loop around the Sun in Jupiter's orbit. There are 2 groups of Trojans, one that leads Jupiter around our star and one that trails the giant planet. Astronomers have cataloged more than 7,000 Trojans to date, but the total population of the space rocks is much higher, perhaps even rivaling that of the main asteroid belt between Mars and Jupiter, Levison said. Lucy will be the first spacecraft to get an up-close look at any Trojan, and its observations could be revelatory. Planet formation evolution models suggest that the Trojan asteroids are likely remnants of the same primordial material that formed the outer planets, and thus serve as time capsules from the birth of our solar system over 4 billion years ago, SWRI representatives wrote in a Lucy mission description. These primitive bodies hold vital clues deciphering our history of our solar system, and may even tell us about the origins of organic materials and even life on Earth. Lucy's trip to Jupiter's neighborhood will be a long and circuitous one. The probe will make 2 different speed-boosting flybys on Earth before heading toward the giant planet. Then, on April 2025, Lucy will perform its first asteroid flyby, an encounter with a rock in the asteroid belt called 52246 Donald Johanson. The Lucy team named the asteroid after paleoanthropologist Donald Johanson, the co-discoverer of the famous Lucy fossil, the bones of a 3.2 million-year-old female of the hominin species Australopithecus afarensis. The fossil, in turn, was named after the Beatles song Lucy in the Sky with Diamonds. The Lucy mission's diamond-shaped logo is a nod to the song, Levison said. Lucy's spacecraft and asteroids near Jupiter after eyeing 52246 Donald Johanson. The spacecraft will trek to the leading Trojan swarm, eventually flying by 4 different asteroids there from August 2027 to November 2028. After that, Lucy will make its way to the trailing group, where it will encounter 3 space rocks in March 2033. Lucy won't linger at any of its asteroid targets. We aim almost directly at them, flying within 600 miles or 1,000 kilometers of their surfaces. And Lucy doesn't slow down for these flybys. It's moving anywhere between 3 and 5 miles or 5 to 8 kilometers per second relative to the Trojan asteroids, Keith Knoll, Lucy project scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said during the news conference. Knoll explains that the encounters happen quickly, with the very best data being collected in just a few hours near the closest approach. Those data, gathered by several different cameras and spectrometers, will teach the mission team about the composition, structure, and activity of the space rock targets. The 12-year mission of the Lucy spacecraft also seeks to study various types of asteroids seen near Jupiter. One of these asteroids is the D-type, which has low reflectivity but is rich in organic molecules. The other kind is P-type, which could also be the D-type but still needs confirmation as Earth samples do not have this kind. And lastly, the C-type, or the most common ancient type of asteroids as per the website of Lucy. Meanwhile, the Lucy spacecraft will specifically be targeting multiple asteroid bodies, namely the 3547 Eurobates, 11351 Lucas, 21900 Orcus, and the 15094 Polymel. To support the study, the spacecraft will be carrying tools that will help the scientists extract data from the mission. Here are some of the devices: a long-range snapper to capture the surface of the asteroid, a terminal tracking camera for wide-field images, and a thermal emission spectrometer to measure the heat. What's more, NASA's mission will not only make history, but will also play an integral part in the study of the early history of the universe. The data that the Lucy spacecraft will be learning from the mission will be used by scientists to expand its knowledge on the early days of the solar system. NASA's total funding commitment to Lucy is $981.1 million, Lori Glaze, head of agency's Planetary Science Division, said during Tuesday's news conference. That money will take Lucy through the end of the primary mission in 2033. Getting ready for liftoff. For the past 8 weeks, the Lucy team has been prepping the spacecraft for flight at NASA's Kennedy Space Center, which is next door to Cape Canaveral Space Force Station. Engineers and technicians have notched some major milestones during this stretch, including the installation of Lucy's high-gain antenna and the filling of its fuel tanks. There has been a lot of hands-on work, Danya Douglas Bradshaw, Lucy project manager of NASA Goddard, said in a statement. The next few weeks were a little busy as well. For example, the team will soon encapsulate Lucy in its payload fairing, the shell that will protect the spacecraft during launch. In early October, the encapsulated probe will be transported to Cape Canaveral Space Force Station, where it will be stacked atop its Atlas V rocket ahead of the planned October 16th launch. Looming over all these preparations, however, was a potential government shutdown. Federal government funding would expire on Thursday, September 30th, unless lawmakers on Capitol Hill can reach some sort of fiscal agreement. Glaze said that NASA is working to secure an exception that would allow the Lucy team to continue prepping for launch, even if the federal government does shut down a few days from now. Glaze says that the request process is underway and not yet completed, although the company is keeping a close eye with what's going on in Congress and with the budget. With that being said, everything is proceeding forward with the launch, she added. Landsat 9. NASA has cleared its newest powerful Earth-observing satellite for a launch into orbit from the California coast on September 27th. The satellite, called Landsat 9, is on track to lift off from the Vandenberg Space Force Base atop an Atlas V rocket provided by the United Launch Alliance. Liftoff is targeted for 2:12 p.m. EDT. The spacecraft of the Atlas V rocket all-range equipment already, NASA launch director Tim Dunn told reporters in a press conference on September 25th. The mission has a 30-minute window in which to lift off from Vandenberg Space Launch Complex 3E, he added. 4 small CubeSats will also launch into orbit with Landsat 9. 2 will study the solar wind and exoplanet atmospheres as part of NASA's research. 2 others are flying undisclosed missions for the U.S. Space Force, Dunn said. Landsat 9 will be the 9th and most advanced satellite to study Earth from above the Landsat program, a joint effort by NASA and the U.S. Geological Survey that has provided constant imagery of our planet for nearly 50 years. It carries a high-resolution camera and a sensitive infrared sensor that together can image the Earth across 11 spectral bands and resolve objects down to 50 feet, 15 meters wide. The satellite should orbit the Earth at an altitude of about 438 miles over the planet's poles. For nearly 50 years, Landsat satellites have documented Earth's changing landscape, Michael Egan, NASA's Landsat program manager, said in the press conference. Landsat 9 will improve and expand upon this unparalleled record for our home planet. Landsat 9 will be able to image the entire Earth every 16 days. When combined with the data of its predecessor Landsat 8, which launched in 2013 and is still in use today, the 2 satellites can cover the entire Earth every 8 days, Egan said. Landsat 9 is designed to last at least 5 years in orbit and replace the aging Landsat 7, which is also in use today. Landsat satellites have been studying the Earth since 1972. That continuous coverage is key of tracking Earth's changes, especially as the planet experiences more extreme weather, powerful storms, fires, and other effects from climate change, mission officials said. It's been a long road to the launch pad for Landsat 9. The satellite was initially supposed to launch on September 16th, but was delayed to September 23rd due to a liquid nitrogen shortage related to the ongoing COVID-19 pandemic. High winds prompted another delay to September 27th. The mission will also launch a minute later than planned to avoid a collision chance with NASA's Calypso CloudSat satellite in orbit, Dunn said. Currently, weather forecasts predict a 60% chance of good conditions at launch time. Star Trek icon William Shatner to take zero-G flight in August. William Shatner will get closer to the final frontier than he ever did in his Star Trek days. The 86-year-old actor, who famously portrayed Captain James T. Kirk in the original Star Trek TV series and several movies, has signed up for an August 4th flight with Zero Gravity Corporation Zero G. The Virginia-based company sells rides on its modified Boeing 727 aircraft G-Force One, which flies in a series of parabolic arcs to give passengers brief tastes of weightlessness. Going weightless will turn a dream into reality, Shatner said in a statement. I've always wondered what it would be like to explore the final frontier, and now I have the opportunity to experience zero gravity firsthand. It will be an incredible adventure. Shatner will be following the footsteps of fellow Star Trek alum George Takei, who played crew member Akuro Sulu. Takei flew with fans aboard a special zero-G flight in August 2016 to help celebrate the 50th anniversary of the iconic TV series debut. And in September 2015, Nichelle Nichols, who played Lieutenant Uhura on the show, took a space-related flight of a different nature. She flew with scientists and educators aboard NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, a Boeing 747 equipped with a 100-inch, 2.5 meters telescope. During the 10-hour flight, Sophia studied several different star-forming regions as well as a protostar in the constellation Taurus. Nichols and her fellow airborne astronomy ambassadors answered fans' and students' questions throughout the flight and during the pre-flight training. Thanks for watching. Let us know what you think by leaving a comment in the section below.